This video tutorial is intended for students studying the New South Wales Stage 6 Software Engineering Year 11 and 12 syllabus, specifically the topic Programming Fundamentals. Credits in this slideshow and this content goes towards James King and his eForge resource. The syllabus dot point we're going to cover today is in relation to data structures. Specifically, this video will cover variables, single and multi-dimensional arrays, and then looking a bit into Python's application of them in lists and hash tables. The other two parts of the dot point, trees and stacks, will be covered in a further video. So, I'm actually going to jump out of here before we begin and just show you a little bit about where we're going with today. In my logic, at times, I have to deal with pieces of data. If that's user input that I need to save and somehow use, if that's data, and in the coming weeks and in the coming terms, you'll look at importing files and dealing with quite big data sets. What's the nature of that data? Is it one piece of data? Is it multiple pieces of data? And what do I want to do with it really ends up dictating what kind of data structure I put it in. We have covered variables so far, but I'm going to go over them again today, and we're going to look at some more abstract or more robust data structures that allow me to hold different types of information. So, a variable. If I need to store a single piece of data, I use a variable. It can be any data type, but a single piece of data. In Python, I define a variable by using that single equals, not a double equals, not a comparative, but that single equals operator. The first time I do that, that both defines and assigns it an initial value, I am then able in my code and in my logic to overwrite that as many times as I want. Yeah, so for example, x equals 10, x is the variable and it's assigned a value of 10, name equals Alice, name is the variable, it's assigned the string Alice. Single operator. Any word, any name for the variable, again, good variable naming, the variable name needs to be indicative or related to the types of data that you're storing. If you wish to have more than one word, so first name, for example, for your variable, you pick your horse. You either do title case, so I'm going to jump out and show you my example again, first name, or you can use underscore, first underscore name. You never, ever use a space. I also wouldn't recommend not title casing it because then if you have 3 words, it becomes very hard to understand what your variable is called. Okay, they're variables, plain, simple, easy. What happens if life becomes a bit more difficult actually, and I want to store not one name, but 1, 2, 3, 4, 5, 6 names here? I can't store them in a variable. What are my options? Well, that's when arrays come into play. A single dimensional array, like that list of names that I showed you, can hold multiple pieces of data with, one dimension of indexes. And we're going to break this down in class a little bit. Nicole and Martin and Fred and Kai and Waleed and Zadie, multiple different values stored in the one data structure, an array called names. Now, how do I differentiate between Nicole and Martin and Fred and Kai and Waleed if they're all in the same data structure? Well, I end up giving them something that's known as an index, okay? Now, names brackets 1 would return the first index, which is Nicole. Names brackets 3 would return the third index, which is Fred. And so on and so forth. So this thing here is called an index. It's how I identify the different values as they're stored in an array. What happens if I needed to store multiple pieces of data for the one entity? So have a think about Connect 4 in your head. When you put down that little circular disk into your Connect 4, there is both a row and a column. There are 2 indices, 2 indices, one for a row, one for a column, for that one circular disk. Another way to think about it is when you buy a ticket at a concert or you buy a ticket at a plane or a ticket on a plane, or on a boat or a seating event, whatever it is. Often when you're buying a seat, there is both a row and a column. Seat 35C, grid row 7, column 4. there are two indexes, both a row and a column index, to indicate one particular entity. That's known as a two-dimensional array, and you can have more dimensions. You can have 3 dimensions, 4 dimensions, 5 dimensions, it doesn't matter. So essentially, an array will allow me to store multiple values. I don't have an array, a multi-dimensional array example, I only have a single dimensional array example. A different data type, another data type or another data structure is a hash table. When you look at a hash table is a structure that maps keys to values, okay? It allows me to store multiple different types of data with a key. So for example, if I wanted to not just store each individual first name or just 2 indexes for the one thing, say I wanted to store a first name, a first name, a last name, an age, a date of birth, and a phone number, all related to the one thing. I can store it in a hash table. That hash table needs to have some kind of unique key at the start that is unique for every single entry. You can then use that hash table and those unique keys in order to be able to draw on this related data. So I can use this unique key value in order to be able to pluck the last name for that key, the date of birth for that key, the mobile for that key. It allows for really fast data retrieval. Now in this example, I only have 1 index, but say I had 40, 50 of these. If each thing is assigned a unique key, makes it really quick to search through, find that key, and pull the data that I'm looking for. We're going to go into more detail on hash tables. Unfortunately, Python changes all the rules. Arrays are multi-dimensional arrays, and specifically, that's meant to say hash tables, sorry, and specifically hash tables aren't really used with those specific names. Hash tables are probably the ones most likely to be used, and they're called dictionaries in Python. They are commonly used, and a dictionary is just a high-level version of a hash table, it's fine. But arrays, as I have just explained them to you, aren't specifically used. You have 2 things, lists and tuples. A list in Python is an ordered collection of items where each item can be made up of any data type. So unlike the example I showed you that was all the same data type, a list can have integers, strings, other lists, yeah? You can store multiple related values in one place, and they are useful when dealing with collections of items where the order is important, and this order might need to change over time. Python lists, like arrays, are okay because they support indexing. So I'm able to access specific elements based on their index, and that's fine. That makes life at least a little bit aligned with arrays. So lists are probably your most common aligned thing with arrays in Python. They are mutable, so here's some new SST. They are mutable, which means after the list is created, unlike some other data structures, I can actually change them. I can append to a list. I can remove things from a list. I can pop things to a list, which removes and returns the last item, and I can extend the list and add other items from another list. So this mutability, or this idea that they are mutable, is one of the key things that makes lists different. Obviously, append, remove, pop, and extend are all inbuilt functions that you can see here, or inbuilt procedures, depending on which one you're looking at, that allow me to do things with lists. So arrays in Python, lists, probably the closest. It is a point of note here, however, you can use an array module and import it, but it doesn't really give you the same level of functionality as a list is. So couple of notes, when I'm talking about an array or a list of things, in Python it's going to be a list. The note is that arrays traditionally have to be of the same data type. Python gives you a little bit of movability in the fact that they don't have to be. Second note, a tuple is the same as a list, essentially, slightly different syntax, but it is immutable, which means all these cool things that the list can do, tuples cannot. And that's it, guys. I think that's where we'll leave it for today. A dictionary you will go and look up the syntax. Lists are probably Python's closest equivalent. Tuples are the same as lists, slightly different brackets, slightly different syntax, and they are immutable.